Well, howdy there, Internet students. This is Mr. Hermanson here. Lesson 10.2. We're going to find the area of trapezoids, rhombuses, and kites. So we're going to have some new formulas for that. To help you understand the formula for a trapezoid, you can look at and try and do this little problem here. But basically what it's saying is if I cut my trapezoid in half like that, and I took the top piece and put it along here, you would end up with one really long parallelogram, and the area of a parallelogram is base times height, but this base is really the two bases added together. The top and bottom, we're going to call both those bases. So that's your base 1 plus base 2 there. And then it's obviously it's half the original height. So that's the first formula we're going to use. Now sometimes we're going to have to use a little math to figure out some of the dimensions we need. Like on this one, you'll notice we don't have the height. So I'm going to just draw in a height line here. And when I do that, you'll notice this is a 45, 45, 90 triangle. So this little line right here would be 14 minus 8, which is 6. And since it's a 45, 45, 90, this would also be 6. And so now I can do my formula. The area is 1/2 times the height times the sum of the bases. And that equals 3 times 22, which is 66 square millimeters. All right. Go ahead, you try it on this one here. Well, if you did that right, you should have got 94.5. All right. Again, on this one, we're going to use some things we know about triangles to help us find all the dimensions we need. Again, on this one, we're missing the height. So I'm going to just draw in a line right there that represents the height. And when we do that, you'll notice we have a 30, 60, 90 triangle. So this little dimension right here is 2, 7 minus 5. And if you remember with 30, 60, 90 triangles, the longer leg is square root of 3 times the shorter leg. So that would be 2 times the square root of 3 is our height. So now I'm going to do my little formula, 1/2 the height, and times the sum of the bases. And that equals, well, 1/2 times 2 is just 1 times the square root of 3. And then 5 plus 7 is 12. So leaving it in simplest radical form, and our answer exact, we get 12 times the square root of 3. Why don't you go ahead and try that on this one, pause it, and then you can check back and see if you got the answer right. So changing that angle to 45 means that this little line here and the height are actually the same then, if we change it in that way. All right. So to find the area of a rhombus or a kite, the formula is the area equals 1/2 times the product of the diagonals. That kind of makes sense, because if we were to take these two bottom pieces and add them to the top pieces, we would end up with a length height that's diagonal 1 and a length that's diagonal 2. Actually, the height would be half the diagonal 1 and the length would be diagonal 2, and that works the same for kites. So we're going to use that formula for these. So to find the area of this kite, we need to know the two diagonals. So the diagonal from A to C is 8 plus 2, which is 10. And from B to D is 4 plus 4, which is 8. And that equals 40. All right, go ahead. This would be a good time to pause and you try it and see if you get it right. All right, finding the area of a rhombus. The rhombus is, we're going to use the same formula, so we're just going to take 1/2 times the 8.4 would represent that diagonal and 15.5 would represent that diagonal. So 1/2 times 8 times 15.5 equals 62. All right, we're ready for your practice. Good luck, and we'll talk to you tomorrow.